Dear students, welcome. I am Manaka Devi, working as an Assistant Professor, Department of Electronics and Communication Engineering, Hindustan College of Engineering and Technology. Today's class, we are going to discuss about the topic classification of continuous time signals. First of all, what is signal? Signal is nothing but it can be some informations. Here we are going to discuss classification of continuous time signals. So these are the major classification of continuous time signals: deterministic and non-deterministic signals, periodic and non-periodic or aperiodic signals, symmetric and antisymmetric signals, or we can call it as a even and odd signals, energy and power signals, causal and non-causal signals. So the first classification, deterministic and non-deterministic signal. The signal that can be completely specified by a mathematical equation is called deterministic signal. Let's say example, x of t equal to u of t. This u of t is nothing but a step signal, or x of t equal to r of t. R of t, it says ramp signal. So the step, ramp, exponential and sinusoidal signals are example of deterministic signal. And the signal whose characteristics are random in nature is called a non-deterministic signal. The noise signals from various sources like electronic amplifiers, oscillators, radio receivers, etc. They are the best example of non-deterministic signals. And the second classification, periodic and non-periodic signals are periodic and aperiodic signals. So the periodic signal will have a definite pattern that repeats again and again over a certain period of time. Therefore, the signal which satisfies the condition if x of t plus capital T equal to x of t is called a periodic signal. The signal which does not satisfy this condition, the signal is a periodic signal. The signal which does not satisfy the condition x of t plus capital T equal to x of t is called an aperiodic or non-periodic signal. In periodic signal, the term t is called as fundamental time period of the signal. Hence, inverse of t is called fundamental frequency. So, inverse frequency and time period both are inversely proportional to each other. And the third classification, symmetric, or we can call it as the even and antisymmetric odd signals. The signal may exhibit symmetry or antisymmetry with respect to time t equal to 0. When a signal exhibits symmetry with respect to t equal to 0, then it is called an even signal. Therefore, the even signal satisfies the condition x of minus t equal to x of t is nothing but a mirror image of the original signal. Yes? So, x of minus t equal to x of t. When a signal exhibits antisymmetric with respect to t equal to 0, then it is called an odd signal. Therefore, the odd signal satisfies the condition x of minus t equal to minus x of t. Let's say an example, cos of minus theta. So, cos of minus theta equal to cos theta. This is a cosinusoidal signal or even signal in nature. And since sine of minus theta is nothing but minus sine theta, the sinusoidal signals are odd signals in nature. And the next classification, energy and power signals. The signal which have finite energy are called energy signal. The non-periodic signals like exponential signals will have a constant energy, and so non-periodic signals are energy signals. The energy E of a continuous time signal x of t is defined as energy E equal to limit t tends to infinity integral minus t to plus t modulus x of t the whole square dt in joules. The signal which have finite average power are called power signals. The periodic signals like sinusoidal signals and the complex exponential signals will have constant power, and so periodic signals are power signals in nature. So the definition for power signal, power P equal to limit t tends to infinity 1 by 2t integral minus t to plus t modulus x of t the whole square dt in watts. For energy signal, E is a constant one. If we say energy signal is constant, the power signal value is 0. So the energy signal, the energy lies between 0 to infinity. For power signal, P is constant. The P value lies between 0 to infinity. If it is a power signal, the energy value becomes infinity. In the last classification, causal, non-causal and anticausal signals. A signal is said to be causal if it is defined for t greater than or equal to 0. Therefore, x of t is causal, then x of t equal to 0 for t less than 0. So this is the condition for causal signal. A signal is said to be non-causal if it is defined for either t less than or equal to 0 or for both t less than or equal to 0 and t greater than 0. Therefore, if x of t is non-causal, then x of t not equal to 0 for t less than 0. When a non-causal signal is defined only for t less than or equal to 0. So it is called anticausal signal. So similarly, the classification of signals for discrete time signals we'll discuss in the next class. Thank you.